Tornadoes beyond the ordinary. When most people think of tornadoes, the image is simple: a dark funnel cloud roaring across the flat plains of Tornado Alley in the United States. That classic wedge tornado, born from a violent supercell thunderstorm, has become the symbol of nature's fury. But the atmosphere is far more creative than that. Tornadoes in reality are a diverse family of vortices, each shaped by unique conditions. Some are slender, ghostly ropes twisting under small clouds. Some whirl above the open ocean, while others dance through fire or snow. A few even spin the wrong way, defying the rules of rotation. These rare tornado types are not only spectacular, but also deeply important for scientists. They challenge our understanding of the atmosphere, revealing just how versatile and unpredictable the forces of weather can be. Landspouts. Tornadoes without supercells. The landspout is one of the most fascinating oddities in the tornado family. Unlike the classic tornado that descends from a rotating supercell, a landspout forms from the ground up. Rotation near the surface, often along boundaries where winds converge, stretches upward into a funnel. Landspouts look different too. Thin, rope-like, sometimes almost transparent until they pick up dust or debris. They often appear under ordinary-looking cumulus clouds, catching communities off guard. Most landspouts are weaker than their supercell cousins, but not always. Some have reached EF2 intensity, strong enough to rip roofs from homes and toss vehicles. Their rarity comes not from how often they happen, but how rarely they are noticed. Because they form quietly, often without the dramatic radar signatures meteorologists rely on. Waterspouts, tornadoes of the sea. A waterspout is a tornado that forms over water, appearing as a swirling column reaching from the clouds to the sea's surface. There are two kinds: fairweather waterspouts, which form beneath growing cumulus clouds in light wind environments. These look delicate, often like spinning straws dipping into the sea, and usually cause little damage. Tornadic waterspouts, which are true tornadoes born from severe thunderstorms that happen to occur over water. These can pack the same destructive winds as land-based tornadoes. Waterspouts can capsize boats, threaten aircraft, and even move ashore, transforming into dangerous tornadoes. They're most common in tropical regions like the Florida Keys or the Mediterranean Sea, but they've been spotted in unexpected places, even the Great Lakes. Gustnadoes, tornadoes imposters. The gustnado is one of the most confusing tornado-like phenomena. Short for gust front tornado, it forms not from the storm's updraft, but along the gust front, the leading edge of cold, rushing air spreading out from a storm. To the casual observer, a gustnado looks like a small tornado, swirling dust, spinning debris, sudden winds. But scientifically, it lacks the connection to the cloud base that defines true tornadoes. Most gustnadoes are weak, causing little more than minor damage to fences or roofs. But their deceptive appearance has made them the subject of countless false tornado reports. They are reminders that the boundary between tornado and not a tornado is not always as clear as it seems. Fire whirls, tornadoes of flame. Perhaps the most terrifying tornado-like phenomenon is the fire whirl, sometimes called a fire tornado. In wildfires, the intense heat causes air to rise violently. If local winds add rotation, that column of hot air begins to spin, drawing in flames, ash, and debris. The result is a rotating tower of fire. Fire whirls can be small, only a few feet wide, flickering like fiery dust devils. But on rare occasions, they grow into monstrous structures. During the 2018 Carr Fire in California, a fire tornado reached EF3 intensity, uprooting trees, destroying homes, and even melting guardrails. Though extremely rare, fire whirls demonstrate that tornado-like vortices don't need thunderstorms. Heat itself, combined with unstable air, can unleash the same destructive forces. Snow meadows, tornadoes of winter. Among the rarest of all are snowspouts, often nicknamed snownadoes. These ghostly funnels form in winter, usually over frozen lakes or snow-covered landscapes. When bitterly cold air flows over patches of relatively warmer open water, convection begins, similar to how waterspouts form. The result is a narrow funnel cloud filled not with rain or dust, but with snow and ice crystals. They look surreal, blending almost invisibly into the snowy background. Snowdales are usually weak and short-lived, but their rarity makes them one of the most exotic members of the tornado family. Only a handful have ever been captured on video, making them prized sightings among weather enthusiasts. Multiple vortex tornadoes. Sometimes a tornado doesn't contain one funnel, but many. Multiple vortex tornadoes are rare monsters where smaller subvortices spin around the main circulation. Each subvortex can have winds far stronger than the larger tornado itself, carving out smaller paths of extreme destruction inside the main track. One of the most famous examples was the El Reno, Oklahoma tornado of 2013. Measuring 2.6 miles wide, the largest tornado ever observed, it contained multiple swirling vortices within its enormous circulation. These hidden whirlwinds created chaotic wind shifts that even experienced storm chasers could not predict, tragically leading to fatalities among the chasing community. Anticyclonic tornadoes, spinning the wrong way. In the northern hemisphere, almost all tornadoes spin counterclockwise due to atmospheric rotation. But occasionally, the atmosphere produces a rebel, the anticyclonic tornado, spinning clockwise instead. They are rare because the conditions that generate them are unusual. Often they form as satellite tornadoes orbiting a larger cyclonic parent. Sometimes they emerge from special storm structures with reversed rotation. Though usually weaker than typical tornadoes, strong anticyclonic twisters have been documented. Their very existence proves that tornado dynamics are more flexible and complex than once thought. Satellite tornadoes. Closely related to multiple vortex tornadoes are satellite tornadoes. These smaller tornadoes form near a dominant one, rotating around it like moons around a planet. Though smaller in size, satellites can still be destructive. Their orbits often bring them into unexpected places outside the main tornado's track, catching communities off guard. For storm chasers, satellites are particularly dangerous, as attention is often focused on the larger, more visible funnel. Tornadoes, outside Tornado Alley. One of the rarest types of tornadoes isn't defined by its structure, but by its location. While the central US is famous for twisters, destructive tornadoes have struck in places few expect. Bangladesh and India experience some of the deadliest tornadoes on Earth, largely because of dense populations and weaker infrastructure. Europe has recorded destructive twisters in Germany, Poland, and the Czech Republic, including a violent EF4 in 2021 that devastated Moravia. Even South America and Africa see tornadoes, though many go unreported. These rare tornado regions remind us that twisters are not exclusive to America. They are a global hazard. Dust devils, tornado cousins. Though not technically tornadoes, dust devils are worth mentioning. They form on hot, sunny days when the ground heats unevenly, causing spinning updrafts of air. Most are harmless whirlwinds of dust, but larger ones can knock people over, flip lightweight objects, or damage small buildings. Dust devils demonstrate that vortex formation is a universal atmospheric process. With enough instability and spin, funnels can form in almost any weather environment, even without thunderstorms.